Okay, last video in this series is to learn about percent yield. So theoretical yield, that is the amount of product that you expect to make. Okay, that's what we've been calculating all along. This is the amount of product, okay, predicted by your stoichiometry. Okay, so you do your stoichiometry and it's the answer we've been getting. Okay. Actual or experimental yield is when I actually do the experiment, how much do I make? Okay, so how much you make when you really do it. Okay, and for a number of reasons, the actual or experimental yield might be less than the theoretical yield. Occasionally, it's more than the experimental yield. So we calculate something called the percent yield. It's what you actually make divided by what you theoretically should have made times 100. That's your percent yield. It's a measure of how well your reaction works. You know, if you get like 90%, you're like, my reaction worked pretty well. If you get 2%, you say, I should probably find a better reaction to do. So I have 100 grams of iron 3 chloride, okay, reacts with an excess of hydrogen sulfide, and I make 58.2 grams of iron 3 sulfide. Okay, this right here is your actual yield. It's telling you what you actually made. So what we want to do in order to find the percent yield is find the theoretical yield. Okay, so I start with my 100 grams of iron 3 chloride. Okay. Again, I'm going to change grams to moles, moles to moles, moles to grams. Okay, so FeCl3, FeCl3. Here, mole ratio of FeCl3 to what I'm looking for, which is the Fe2S3. Okay, if they give me the actual yield of something, I want to find the theoretical yield of that same thing. Okay, Fe2S3, Fe2S3. All right, so 1 mole of FeCl3 is going to weigh 162.2. Okay, our mole ratio is 1 to 2, and 1 mole of Fe2S3 weighs 207.88. Okay, so it's going to make 64.1 grams of Fe2S3. This is your theoretical yield. This is how much you should make. Did we make that much? Not quite. Okay, so the percent yield is your actual 58.2 divided by your theoretical 64.1 times 100. And this reaction worked pretty well. We got a 90.8% yield. Okay. So the second question I'm going to ask you, same conditions, how many grams of the other product, HCl, are produced? Assume that we're going to get the same yield for the HCl. Okay, so if this only works 90.8% well to make Fe2S3, that's going to apply to the HCl too. So what we're going to do is first just figure out how much HCl would we make if my reaction were perfect. Okay, so I start with my 100 grams of FeCl3, the all familiar grams to moles, moles to moles, moles to grams. Okay, FeCl3. Okay, now we're going to try to get to HCl. Okay, so 1 mole of this is still 162.2. My ratio is 6 to 2, and this weighs 36.46. Okay. So that would give me an amount of HCl that I would make, but let's not forget that the reaction only works 90.8%. So I'm also going to multiply by 0.908, or 90.8%. Okay? And then we'll get an answer of 61.2 grams of HCl. Okay, and that's percent yield. It's a pretty simple little piece of this. And that's pretty much it for stoichiometry.